Thanks for being here with us today. We are pleased to welcome you to join the Steel Connect webinar with the topic of Crafting Resilient Roof Design for the Load Challenges, brought to you by NS Plus Group Malaysia. So just do some housekeeping here. So we appreciate very much if you can mute your mic during the session, and you can raise your question from time to time by post your question into the Q&A chat box with your email address. We will try our best to answer your question in the end of this webinar. Otherwise, we return an email to you to answer your questions. For architects, engineers who wish to collect your LAM or BAM CBD points, kindly stay through the entire webinar, as there will be a survey form required to be filled at the end of the session. All right, thank you very much. Okay, right. So for information, we will be doing something special in the Steel Connect webinar today. So in order to make you awake and focus on my content, we created a quiz session in between my presentation, and you need to get all the answer right. All right. So why we have this so-called special arrangement for today? So because that we would like to reward you, because for whoever to attend this Steel Connect webinar is our supporter, because we are not announced of this quiz, but it's still joining us to hear from us. So we'll be giving out all the datum tickets today. All right. Of course, there will be no free lunch, so you need to participate in the quiz session and give the right answer. Then you will be rewarded with the tickets. So we'll be giving out 8 tickets of the datum KL, and 4 tickets of the datum green, and 4 tickets of the datum plus. So when I open the quiz to all of you, the first 2 or the first 4 person who give the right answer will be rewarded with the tickets. So it really depends on the quiz is giving out 2 or 4 tickets. All right. So you will be informed in each quiz session. So the way to play is very simple. When I post out the question, and then I will elaborate more about the quiz, then I will say, please start to answer your question. Then you'll be giving 10 seconds to type your right answer into the chat box. Just bear in mind that you need to type your answer into the chat box, but not the Q&A box. If you type into the wrong chat box, I can't really help you on that. All right. So my colleague will be announce the winners in the end of the webinar, and she will be requesting you to give some personal information, and then so that we can deliver the tickets to you. Right? I hope you'll be enjoying this webinar with the full excitement. Let's start our webinar today. Right? Okay, so this is our topic to sharing today. Is very straightforward. So there will have a more 4 main section here. At first, we will explore the concept about of the architecture or the structural product for coated steel roof and wall. Then after that, I will share about the loading supported by the steel roof and wall, because today we're talking about all the load challenges on the products, right? So of course, we will explore about what kind of loads is supported by the roof and wall, especially in the coated steel. Then lastly, I will compare the wind uplift capacity and how the gravitation load is supported by the coated steel product and also the UPVC roof, right? And then by the end of the session, as I mentioned just now, we are open for Q&A. Then I will answer the question from the floor. So just to share with you, this is not a lengthy knowledge sharing, but just they will consist of a few information might be worth for you to take away after this session. All right. Okay, without further ado, let's start with the first topic of today, which is to identify whether the coated steel roof and wall is an architecture or the structural product. Because today we're talking about the loading challenges that's supported by the coated steel roof and wall, right? But how come if it is an architectural product, why there's a loading acting on it? So this is what we're going to explore in this section. Okay, steel roof and wall is widely used in different type of buildings, right? Range from, let's say, infrastructure, industrial, public utilities, commercial, residential, and etc., etc. So the main function of the steel roof and wall is to protect the residents inside the building from the weather, and then secondary purpose also is providing the aesthetic pleasing to the building. And that's the reason why the base steel is very important, and it must be well protected by the right metallic coating, so that it will not be easily deteriorated. When the base steel is protected, then only coated with the color, so that they can see the sequence, right? Because the base steel is very important, because you have to sustain a certain loading, so that's why you need to be well protected. Then only that we coated with colors for the design purpose. So colors provides a visual delight side and design option, whereas the base steel is offered a sufficient strength capacity to support or resist loading that act on the coated steel roof and wall. So this is how the coated steel roof and wall protect us from the extreme weather nowadays, and it secure the building from breaking in also. So in short, the coated steel roof and wall should perform aesthetically and also structurally. Right. Since coated steel roof and wall need to be performed aesthetically and structurally, right? So who designed the coated steel roof and wall on the building? All right. Is architect designed the coated steel roof and wall? Yes, it should be because they are the professional who design the building that present aesthetically, right? However, engineers should be involved too, right? It is because he or she designed the coated steel roof and wall that is structurally sound. So as such, in short, yes, both of them involved in the designing the coated steel roof and wall, right? So come to here, some of you maybe still have the question is, architect and engineer both involved in the coated steel roof and wall design. So in that case, is coated steel roof and wall shall be considered as architecture or structural product? In addition, who should be responsible to check and ensure the product can resist or support loadings? Is architect or the engineer, right? Some may not be clear, right? So let us take a step back to the basic and explore that what is the architecture and what is engineering. So architectural work should be focused on the building and the physical structure design. So in layman, it means that what kind of building or structure he or she designed it, right? So whereas engineering work is focusing on the construction of the technical and the structural aspect. So in short, is how the building or the structure is being constructed. So there's two different aspects in two area, right? So based on the last description of the architecture and the engineering school of work in the previous slide, the coated steel roof and wall actually is positioned in a very awkward position, right? It's like a kid that without a mom. So in one hand, architect think that I am responsible for the coated steel roof and wall design and the rainwater runoff calculation for the steel roof only. And the steel roof and wall structural performance should be responsible by the engineer. But on the other hand, the engineer think that, yes, I'm responsible for the structural design up to the purlin or girth. The steel roof and wall should be under the architect design because it's architectural products. So is that true that none of them should be responsible for the product performance in terms of the loading support or resistance, even though both of them, both of the profession involved in the coated steel roof and wall design, right? Okay, let's explore it a little bit more detail about the architect and the engineer do in the coated steel roof and wall design. Right, architect is in charge of the select the right profile, the colors for the coated steel roof and wall design, and they do the detailing methods, and also responsible to calculate the rainwater drainage from the roof, right? And the engineer is responsible for the loading design, the building structure design, and their liability is maybe only up to the roof purlin or the wall girth design. So whatever components or the cladding over the roof purlin or the wall girth shall not be responsible by the engineer, right? So based on the responsibility of the engineer and the architect as described, should coated steel roof and wall considered as architecture or structural product? Hard to say, right? It's still in the dilemma stage. So let's analyze it in detail in the subsequent slide. Okay, based on this building sketch, the building will be exposed to the wind load that act on the roof and wall, right? So in addition, the human traffic load also act on the roof because people need to walk on it to survey this, maybe to do some integration of the system like solar panel or safety lifeline or other things on it. So they will be having the gravitational load on top also. So now let's analyze each component on the buildings, all right? Okay, start with the purlin. Okay, purlin, there's no argument at all. This is a structural product because it's mainly used to resist wind load and support downward load at the same time, which is the human load, okay? This is for the purlin. And wall girth is the same as purlin. We can say it 100% structural product because it is used to resist the wind load only, all right? Okay, now let's take a look at the coated steel wall. The cladding is provided aesthetically pleasing for the building design. However, in the same time, it is used to resist the wind load. All right. So now let's take a look at the roof. It is used to provide the visual delighting and also drain out the rainwater effectively. At the same time, it is used to resist the wind load and support the human traffic load. So therefore, coated steel roof and wall is considered as a architecture and structural products. So it's not either one, all right? Okay, now come to the interesting part. It's the first quiz of today. So we're giving out two datum KL tickets now with this question. So is coated steel roof and wall an architecture or structural product? A is purely on the architecture, B is structural, and C is architecture and structural product. You can start your answer now, giving 10 seconds. Right, just if you haven't get through all the slides just now, you can just guess on it. All right. All right, time's up. So the answer is C, is architecture and structural products. For those who get the answer right, then you may be the winners that will be announced later. All right, let's continue on our presentation today. Okay, so normally the workflow in determining the suitability of the coated steel roof and wall product to be used in a project is started with the architect, right? So the architect, maybe he or maybe she, will choose the product for the building envelope design. The material, the profile, the color will be chosen, right? That's the reason why coated steel roof and wall product is always deemed that it's architectural product. But that's the next step. Next, actually, the architect should pass the information about the product performance capacity to the engineer. Then the engineer will calculate the wind load, and then they will compare the product performance capacity with the design wind load. All right. So how the engineer to design the wind load? Okay. In general, engineer will calculate the wind load either by using BS 6399 Part 2. So based on the clause 1.5.2 on page 5 in this, as shown here, it's clearly stated that the roof and wall or cladding units and their fixing should be considered as a loaded area, and it should be checked by engineer. So the engineer will base on that to calculate the wind load and check whether the roof or wall sheet is able to sustain the wind load. All right. So optionally, engineer can also use another code. It's called MSEN 1991-1-4. So refer to this clause 1.1 in the bracket 1 in the page from the page 9 of this code. It's also stated that the cladding units and their fixing should be considered as a loaded area, and it should be designed and checked by engineer. All right. So the engineer will check on the things, and based on the code that I mentioned just now, which is either BS 6399-2 or MSEN 1991-1-4, and then they will compare the design wind load to the product wind uplift capacity. The result of the checking can be either the engineer approve the product because it is able to resist the wind load, all right, or the engineer will advise architect to select the thicker materials or choose the other product because the wind load capacity of the original product is lower than the calculated wind load. So this is the engineer decision after they calculate the wind load, all right? Okay, we are talking about the wind load on the roof and wall, but how the wind load is added on it. In addition, what other load is supported by the coated steel roof and wall, right? So we will explore in this section now. Okay, basically they will be having the two major forces act on the coated steel roof and wall. The first one is simply we call it as a push and pull force, which is the wind load that create the negative or positive pressure on the coated steel roof and wall. It causes the roof or the wall either lift up or suck into the inner space. However, in most cases, lift up action is happen. All right. So the second one is called the gravitational force. This is the pushing down force that caused by the gravity. So normally the force will be acting on the roof and it caused by the human traffic or the temporary construction load. All right. There will be two types of the gravitational load. There will be two types of the forces that may be act on the coated steel roof or wall. Okay, so let us explore it in one by one. So let's start with the wind load. Okay, the concept of the wind load act on the roof is very simple. So according to the hydrodynamic concept, when the fluid is moving very fast, the pressure will getting low. So in reverse, the pressure is higher if the fluid is moved slow. All right. So hence, when the wind flows in the high speed on the roof due to the aerodynamic, it creates a lower pressure compared to the inner space of the building when the air is static. All right. As such, the higher pressure inside of the building will push the roofing out, and it is how the uplifting effect happen on the roof. All right. So at the same scenario will happen on the wall too. The higher pressure from the inner space will push the wall outwards when the low pressure is happening inside due to the high wind speed outside. All right. So normally the wind uplift effect on roof is more severe than pushing out of the wall. That's due to the many reasons such as the aerodynamic effect, the support spacing, and also the wind speed, etc., etc. So normally that due to all this, you hardly to see the wall fill in wind, but you will see more on the roof. Okay, this is the reason you will see the roof flying off more often on the more than the wall in the normal scenario. So I think these two videos, these short clips is the last thing that you want to see in your building design or you reside in it. So, but just to share, this is so-called the most extreme case that when the roof is flying off due to the wind load, the extreme wind load, all right? Okay, let's go to the next slide. Okay, as I mentioned just now, the short clips that you see just now are the most extreme cases of the roof failure. So, in other angle is maybe someone you ask, does it mean that as long as the roof does not fly away, it means there's no failure? So I can give you the certain answer is no. As such, we shall define well about the principle of the roof capability in terms of the resist the wind load. In other words, is how we judge the roof is filled in the wind load even though it does not fly away. All right. I hope the following info maybe can help you to choose for the right product in your projects. All right. Okay, the first one is we call it as a so-called serviceability stage. So what does it mean is we should not allow the roof over deflect or bend upwards until damage any mounting system on top of the roof, such as the safety lifeline or solar panel system or even any flashing that attach on top. When the roof is over deflect or bend upwards, it will make the mounting system disengage and then it will fall from the roof. All right. It is normal that the roof will deflect and bend upwards when the wind load is happening on roof, and it happens whenever the wind is flow through the roof. So the roof shall be able to back to the flatness when the wind disappears. It shall not be permanently bended after the wind load is gone. So it means that when the wind is coming in, the roof actually is allowed to be bending up, but it's not that severe. You cannot accept that the roof is actually bent up like a balloon like that. So it actually allows it to be deflect or upwards, but it's subject to the principle that when the wind is gone, the roof have to back to flatness as the original position. All right, this is how the principle is. So the next is about the strength stage. Strength in this stage that the roof might be already filled in strength. So in layman is no longer can continue support the wind load as guaranteed. The first principle is that the roof shall not cause water leakage immediately when it is filled in strength. So which means that even though the roof is allowed to be filled in strength, but it shouldn't bring you that it have to so-called the instant water leakage when the storm is coming in. So secondly is the roof sheet shall not be break into the pieces, or any item will be fly off from the roof when it is filled in strength. So what does it mean? I purposely put into the red box here. So because I want to elaborate more about what does it mean. What does it mean by the roof should not be break into pieces and no fragment or broken pieces to be fly away. All right. Okay, for the long length roof sheet, it should not be break or burst into the pieces like balloon when it is filled in the resisting wind load. Just like just now the short clip that you see in the previous few slide, when the roof is filled off, it doesn't really burst like a balloon. It will flying by pieces, all right? Or maybe you buckle by locally. So it's because that the broken fragment or any small components that flies scatteringly will cause the hazard to the public. So I will explain more in detail in the next section of this webinar. But just bear in mind that actually the full pieces of the roofing sheet, if can break into the pieces, actually is not acceptable. All right. Another quiz. So this is we're giving out another 2 tickets of that term KL. So which is not the principle of roof capability in resisting wind load? A, the roof return to flatness after wind load disappear is not important. All right. B is no immediate water leakage when the roof fill in the wind load. C is a roof should not be broken into pieces and fly off. So which is not the principle of roof capability in resisting the wind load? You can give your answer now. 10 seconds. So this one a bit tricky, but the answer is pretty clear that which one is correct, right? All right. So time's up. So the answer is A. All right. Congratulations for those who answered the right answer. To give the right answer. Okay, let's continue. Okay, so now we understand about the wind load and how to define the principle of the roof capability in resisting wind load. All right. However, maybe some of you not sure that how the wind load is calculated, right? So I will share it to you now. So as mentioned earlier, there are two design standards can be used by engineer to calculate the wind load in Malaysia, which is either BS 6399 Part 2 or MSEN 1991-1-4. So actually, both design standards are sharing the similar design concept, and the wind load design method is quite similar too. So no matter which standard is used or referred by the engineer, the factors that affect the wind load design are same. So let's explore it, all right? Okay, the factor determine the wind load act on a building, including including the wind speed, right? The first one. The second one will be the altitude, which is the location of the building, whether at the low or the highland. Then the third one will be the terrain, which is the site is at the plain field or surrounded by the hills or in the mix, right? And lastly is the location of the site that is at the seaside or in the mainland, right? This will affect the wind load. So these are the geographic factors that cause the wind load change according to the location of a building. So as such, we cannot assume that the wind load will be the same when the building located at a different site, even though it is the same building design. So let's put an example like a building located at the seaside at Selangor and the same building, same design located at the mainland of Pahang, the wind load will be different. All right. Engineers should check and design the wind load of every building unless they have the sufficient experience or the sufficient past project reference. They're aware that the wind load difference at the different site is negligible. Let's put an example. This particular engineer already designed a lot of buildings in this Pahang area and the same area. They roughly know what is the wind load at this particular area with this kind of building design, so they can guess that this is the wind load can be used. Otherwise, actually each building design, you need to check on the wind load. So this is the geographic factors. But we have another factor that affect the which is called building included like building shape and size and like building distance, and then the opening design on a building such as the size and the number of windows and doors, or whether it's an open or enclosed space. And lastly is the roof type and roof gradient. So most of the people may not aware that the type of roof and the gradient is important factor that determine the wind load. So they just assume that this is part of the building design by architect, but actually it's no. So I hope now we all understand that there are at least 8 factors, maybe more than that. There will be at least 8 factors that determine the wind load act on a building. There will be having 4 in the geographic factor, and then another 4 in the building design factor. Okay. All right. So just give me a chance to sidetrack a bit on about the myths of the wind load. Because I think most of you always hear that somebody will ask you that, hey, what the wind speed capacity of my roof is. And then they even maybe ask you is, can my roof resist 75 kilometer per hour or 35 meter per second wind speed? So based on the last 2 slides, we understand that the wind load is determined by at least 8 factors, and the wind speed is only one of the factors. So as such, engineer is not able to give you the answer about what level of wind speed the roof can resist. They only can tell you that I use XX wind speed in my design and the windows is XX value. So what does it mean? I will explain to you in the subsequent slide on that. So by right, the working flow is started with the engineer design. The wind load based on the 2 standard I mentioned either is BS 6399 Part 2 or MSEN 1991-1-4. I refer to these 8 main factors. Then he or she will get a design wind load in the unit of kPa or kilonewton per meter square. The engineer can either pass the design wind load to the architect to check it with the product wind load capacity, or he or she can help the architect to compare the design wind load with the wind load capacity of the product, which is shown in kPa or kilonewton per meter square also. All right. If the wind load capacity of the product is higher than the design wind load, it passed the requirement. The product can be used in the project. In reverse, the product is still in supporting the design wind load. Okay. So as you can see that the unique comparison in between the design wind load and the wind load capacity of the product is kPa or kilonewton per meter square. It is not meter per second or kilometer per hour comparison. So we do not compare the wind speed capacity, but we compare the wind load. All right. Okay, so now come to another next exciting quiz subsequently. Okay, so this one will give out 2 datum KL tickets also. So what is the terminology is used to define the roof and wall product capacity in resisting wind is? It's a wind speed capacity, wind load capacity, or wind value capacity. You can give your answer now. We have 10 seconds. I think this one is pretty straightforward. I think a lot of people will fighting for the answer. All right. Okay, time's up. So yes, the answer is B, the wind load capacity. So we always use a wind load capacity to compare the product performance. Okay. So just now, we are talking about the wind load. So I hope all of you catch about the concept of the wind load and how to compare with the roof product capacity. So now we take a look of the gravitational load that happen on the roof. All right. We are not talking about the wall because you have nowhere to implement the gravitational load onto the wall. So we are focusing on the roof now. Okay, some of you come to here, maybe you ask that shouldn't be the roof is the highest level of the building. So where the gravitational load is coming from, right? Because there's nobody on top already. Yes, there's not much gravitational load that's supported by the roof, but it does not mean that you no need to check on the design. But it just doesn't have the superimposed dead load or the live load that act on the roof, but you still need to check on it. The roofing sheet must be minimally able to sustain the load from the human traffic during construction. Okay, the first thing. Okay, in other words, that it can be used as a working platform for workers during installation on roof. Imagine that not stand by a human, you have no way to install it on top of your roof truss. Okay, this is the first thing, first thing that you need to comply. Then, in addition, it can be used to support the construction load temporarily, such as the bundle of the roofing sheet, the insulation material, a small machine, etc., etc. Because whatever the thing that you cannot always lift it from the ground, right? Because you're wasting the construction time. Sometimes you need to put a few construction material on top of your area that already have the roof as a supporting platform. And then last but not least, the roof must be able to support the human traffic load during the maintenance or the system integration work, such as the solar panel installation. So which means that other installation, everything, you still need to ensure that this roof, you still can walk by the human after many, many years, because people still need to go out and do maintenance, do inspection, or maybe sometime if you need to install the solar panel on top, you must ensure people can walk on it and even work on it. All right. Okay, in the last section, we discussed about how to define the principle of the roof in supporting wind load. So now let's take ability in supporting human traffic load. Okay, firstly, this is about safety. Okay, the roof is defined as capable to support human traffic load when it is able to let human walk on it without fall off. He or she will not feel wobbly when walk on it, and the roof should not create any risk in making humans sleep. So this is the thing, that the basic principle that the roof must be create a very safe platform for people to walk on it and work on it. All right. Secondly is there will be no permanent damage should be found on the roof sheet when temporary loading is disappeared. So the permanent damage such as the opening the side lap or local tendon, all these things. So which means when people walk on it after it's walk off the roof, you shouldn't see any damage on the roof. Then it defines that this roof is safe to support the human traffic load. All right. Okay, the way we assess or compare the product capacity to the gravitational load is very straightforward. So the engineer will define the design point load act on the roof based on the international standard. And then he or she will compare it with the spanning capacity of the roofing products, which is the maximum support spacing in between the purlin. As long as the spanning capacity of the product is greater than the design point load, the product can be used to support human traffic load or the temporary construction load. All right. Okay, now it's quiz number 4. So you're giving out another 2 datum KL ticket. So which is not the principle of the roof capability in supporting human traffic load? A, humans should be safe when walk or work on the roof. B, sleep on the roof is acceptable as long as the human will not fall off from the roof. C, no permanent damage happen on the roof. So you're giving 10 seconds. You can give your answer now. I think it's pretty straightforward. I think a lot of people will give the right answer. All right. Another 3 seconds. Okay, time's up. Yes, the answer is B. You sleep on the roof is also not acceptable because you must provide a very safe platform to people to walk on it and work on it. All right. Okay, let's continue. Okay, now we talk about the product performance capacity. So no matter we talk about the wind load or the human traffic load or temporary construction load to be supported by the roof, it is fully rely on the product performance capacity. So we need to ensure the product performance capacity is always higher than the design loads, right? But what is the product performance capacity and how we define it? So let's check it out in this subsection. Cool. Regarding the method to assess the wind load capacity of the roof products, it is clearly stated in MS 2005, clause 4.3.2. I'm not going to talk about it in detail. I will highlight a few important points. Okay, the clause is stated that the wind load capacity can be determined either by the calculation, it's stated here 1993-1-3, or the testing standard according to MS 2523. All right. The calculation or testing is only applicable for the trapezoidal or the sinusoidal sheets, which is either is a screw, which is the screw fixed corrugated product that we commonly name it in the industry. Then other products such as tiles, standing seam, or the concealed fixed sheets, the load test is not applicable because these products are normally designed by testing. So in other words, the standard allows user to adopt the testing standard from the manufacturer, right? So regarding the spanning capacity in supporting the human traffic load or temporary construction load, the MS 2005 gives us a guideline too. According to MS 2005, the spanning capacity of a roof product to support the gravitational load is not the mandatory. However, if the product performance needs to be confirmed, the court suggested that we refer to the testing standard of MS 2523, which is particularly on the clause 7. All right. However, the standard also gives us another option that actually we can adopting the result from the manufacturer based on the method used. So as long as the manufacturer can give you the answer how the test out the spanning capacity actually can be used on that. All right, this is open option. Okay, so refer to the MS 2005, it gives us the clear direction that in how to determine the wind load and the concentrated load capacity of the roof products, right? Especially on the wind load capacity, we can choose either by testing or calculation, right? So however, can we really determine the wind load capacity of a roof product by calculation? This is the first question. Or in between the testing or the calculation, which is the best solution to get the reliable result of the product performance? Is either by testing or calculation. Let's say you come to the T-junction that there's a supplier or the manufacturer give you two things. They give you the testing and also give you a calculation. So which one actually is better? All right. So we share with you with our experience. All right. So when you intend to rely on the structural calculation to determine the wind load capacity of products, but before that, we should ask ourselves a few questions, right? So the first thing is, are we able to produce the calculation that cover all the possibilities of failure for screw fixed products? Is such as the tension failure of the screw, the pull out, the pull over, the pull through, or the cross distortion of the sheets. So whether all these scenarios can be calculated or not. Okay. So if you intend to use the concealed fixed product, are you able to calculate the clipping effect or not? All right. And then, or you are using the seaming product. So are you going to able to calculate the unseaming effects? So for info, we cannot base on the section moment capacity to determine the capacity of the roof product in resisting wind load, because the connection failure will be happening before the section failure. So what does it mean is, in the previous slide I shared with you, right, you should not allow that all the roofing sheet to be burst like balloon, to break into pieces. So you cannot use a structural calculation product to calculate the section moment capacity and assume the wind load, because normally the steel will not burst it, but it will fail in the connection. So either it's a screw fail, pull off, pull over, or the unclipping, or maybe unseaming happening, then the roofing sheet will be fly away. So this is how the roofing sheet will react. So are you able to calculate all this with the design calculation? So maybe yes, maybe no, because if you use a certain very high, and let's say for example you use a finite element calculation, maybe you can achieve that, but you need to try a lot, try and error. So the most straightforward way, the best option to determine the coated steel roof and wall capacity is by testing, because the result is close to the real world, so the result is more reliable. All right. Yes, there are few reliable testing standards actually available in the worldwide, such as the Malaysia standard, Australia standard, American standard, and China standard. And even for the concentrated load test or human traffic load test, we also have the Malaysia standard to guide us, and also Australian standard. Maybe more than that. But in my knowledge, in our knowledge, this is what we available in the worldwide to test on the coated steel roof and wall. All right. Okay, I hope we are all clear about the wind load and the gravitational load or human traffic load act on the roof and wall. So we also understand that the best method how to determine the product capacity, right? So now come to the very interesting part. We see how the coated steel roof and UPVC roof react to the wind load, right? Okay, in order to do a reliable study and share with all the audience today, we did a few internal tests on the UPVC roof and compared it to the coated steel roof. We selected the UPVC roof product that is look like the coated steel roof product, which is, let me just point it out, which is as shown in this graphic. This is a profile that we use, which is the UPVC and coated steel. We share with the same profile. Then we conducted two sets of the testing to compare, we conducted two sets of the testing to compare the product performance capacity in the wind load. The case A, as shown in the table above, is comparison of the 0.42 BMT of the coated steel to the 1.8 mm thick UPVC roof. Both cases is based on single span, 1.2 meter spacing. And the case B is a comparison of 0.48 BMT coated steel roof to 2.5 mm thick UPVC roof. Similar to the case A, the specimen are set on 1.2 meter single span. All right. And then the wind uplift testing to case A and case B was conducted by using the pressure rate located in our laboratory in Singapore. We adopted the Australian standard of AS 1562.1 and AS 4040.2 to assess the roof product performance according to the wind load. So how different the roof product react to the wind load? So let's explore it now. Okay, let's start with how the coated steel react to the wind load. Okay, this photo is a coated steel roof specimen set on the pressure rate. I mean the rate that you see just now. It was taken before the wind load was starting or act on the roof, or in layman term is before the wind load is coming in. All right. So when the wind load was starting act on the roof, some local stresses will appear on the coated steel roof surface. The local stresses mark will become more and more severe when the wind load was increasing. All right. And then eventually the coated steel roof will fail by the local buckling. And then the wind load achieved, when the wind load achieved the maximum level. So in simple terms, is the roofing sheet will bend up and is not able to back to the original shape when it's in the local buckling. Let me just point out, when in the local buckling case is happening. So this is called local buckling. All right. Okay, let's go next. Okay, this is the photo of the testing specimen after it is filled in the maximum wind load, and all the air was released, or the air load, or the wind load is disappeared. So which means we tested everything, we released all the air and let the roofing sheet to stay as what it is, as you can see. Right, we investigate the coated steel roofing sheet in very detail now, right? So as you can see that on the left-hand side of the testing specimen, when the wind load is gone, the coated steel roofing is able to back to the original shape or the flatness, as you can see here, right? Because based on the previous slide, all the roofing sheet will bend out when the loading is coming in. But when the window is gone, it will back to the flatness. Whereas the local buckling is observed on the coated steel roof on the right-hand side, which is this one, all right? This is how the coated steel roof is designed for. When the roofing sheet fill at the maximum wind load, the damage is only happen locally. As such, it will reduce the risk of the water leakage happen immediately. So importantly is, the coated steel roof sheet will not burst or explode into pieces and violently scattering around in the certain outbursts. So which means you will not flying around like the balloon burst it out. All right. So this is how the coated steel will react and feel. All right. Now let's see how the UPVC roof react to the wind load. Okay, this photo is shown that the same as the setup as shown in the previous slide, but the specimens have been changed to the UPVC roof. So when the air is starting to increase underneath the UPVC roof, the roofing sheet is bent up instantly. All right. The bending up effect become extreme severely when the wind load was increasing. The interesting part is based on our standard testing procedure. We normally will use L angle steel bar to protect the roofing sheet to be blown off in the test. Let me just show you in the okay. So this is the L-shaped angle. Initially, you see this is a position because this one is protect the roofing sheet to be fly off. All right. Okay. However, due to the UPVC roof is too soft and it's bent up extremely, you have no choice. Then we remove the L anchor bar in the middle of the test. So what we can do is just let the technician and engineers stay far away from the testing rig. For information, this is the first time we encountered this issue because none of the roofing sheet we tested before is as soft as the UPVC, right? So in the end of the test, the UPVC roof is explode and it broke into the pieces and outburst when the wind load is achieved the maximum level. So it's luckily that our technician and engineer stay a certain distance from the testing rig, right? So this is how it looks like. Okay, based on the last sharing about the extreme bend out of UPVC roof, maybe some of you still can't really imagine how the difference of it compared to the coated steel roof, right? So let me do a side-by-side comparison to you. So in engineering term, when we talk about the roofing sheet bend up, we call it as a deflection. Okay, let's see how different of the deflection of coated steel compared to the UPVC roof. The photo as shown on the left-hand side here, all right, is a coated steel roof. When it is pressure with the wind uplift force, you can see some local stresses mark happen, right? Okay, but the deflection bend up of the roofing sheet is very minimum. It has been at a certain distance to touch the L angle steel bar as highlighted in the white. So what does it mean is, as I mentioned just now, in our normal testing procedure, we will be having the L angle steel bar to protect the roofing sheet fly off. As you can see, this steel bar up, there's a quite distant away. All right. So whereas the UPVC roof, as shown on the right-hand side, okay, is deflected and bent up severely. It will in touch with the L angle bar if we did not remove it. So come to here, maybe some of you still can't really imagine how soft the UPVC roof is and how it deflect and bend up severely during the wind load react on it. So let me just show you two videos. Okay, so this is the time-lapse video that was taken during the wind uplift test. And this is 1.8 mm thick UPVC roof. As you can see in this video, the deflection or the bend up of UPVC roof is very severe. And this is almost over the depth of the testing rig. As you can see here in the middle of the test, we remove the L angle steel bar because it almost touched it when the wind loads come to the maximum. All right, so this is for the 1.8 mm. All right, let's see any better if we increase the thickness to 2.5 mm thick UPVC roof. Yes, you can see that the deflection, the bend up rate is slower, and also the bend up is also lower than the 1.8 mm. However, the bend up is still much severe compared to the coated steel roof because it's too soft, and eventually it will fail by breaking at the connection. All right. So this is the photo of the testing specimen or UPVC roof after it's filled in the maximum wind load, and also all the air release, or we can say it in layman is all the wind load is disappear. As I mentioned just now, after we test the specimen, we will release all the air and see how it's happening to the roof. So let me share the result or the finding in details one by one. Okay. So okay, the UPVC roof sheet cracked and broke into small pieces when you feel in the ultimate wind pressure. And the worst case is it's not able to return to the flatness after the wind pressure is disappeared. And also that the screw head will fly off when the pressure comes to the maximum level. So these are the findings after we test the UPVC roof. But the downside of this outcome, what will affect us when we come to these three main failures. So I will explain it one by one. So when the roofing sheet cracks severely, it creates a big passageway for the rainwater instantly. Consequently, the water leakage will happen immediately right after the roofing sheet is filled in wind load. So you just imagine that under the storm, in a heavy rain, then it can break into the pieces like that. Then it will create a very big opening for the rainwater to coming in. So the water leakage will happen immediately. So in normal cases, the roofing sheet will not outburst into pieces. However, it happened on the UPVC roof. As you can see in this photo on the left-hand side, the UPVC roof sheet filled in maximum pressure, it will break into the pieces and outburst violently in all around the place. So the sharp pieces that flying in a high speed might create a hazard to the public. On the other hand, the fragments from the outburst of UPVC roof, the screw head of the special, so-called the special fastener, will be ejected out and flying off when you achieve the maximum holding force. So refer to the photo on the right-hand side. Okay, hold on now. Let me just show you that thing. The left-hand side, the screw head will broke into the pieces after it achieved the ultimate strength. The nylon hexagon head, the galvanized washer, even the rubber washer will be flying off around in the place in high speed. So this is not only creating the risk to the public, but it's also caused the rainwater leakage happen immediately. So in normal cases, when the coated steel roof is used, the screw head will not be flying off because this is a monolithic screw that will be used for the connection. But because that UPVC, they try to achieve that anti-corrosion, then none of the component that to be corroded. So they're using this kind of the screw with the screw head with nylon, but it will be easily detached when come to the high wind load. All right. Okay, based on the last few slides, we are now aware that the outcome of the UPVC roof when it filled in supporting wind load, right? However, how much different of the wind load capacity of the coated steel roof compared to the UPVC roof? So let's check it out. Okay, refer to this table, the maximum wind load capacity of 0.42 mm BMT coated steel is 7.94 kPa. But UPVC roof is only to support 6.94 kPa. So the coated steel roof is 14.4% higher than the UPVC roof. It's quite high, right? But this is not the highest. Let me show you the next table. The maximum wind load capacity of the 0.48 mm BMT is 11.9 kPa. But 2.5 mm thick UPVC roof achieved the maximum strength of 7.15 kPa. The differentiation in between two is 66.4%. Right? So this is something very interesting, but the intrinsic part is, let me just explain in detail is, when the BMT of the coated steel increased from 0.42 mm BMT to 0.48 BMT, we give you that 50% increase in the capacity in terms of the wind load resistance. However, when the thickness of the UPVC roof increased 0.5 mm, it just gives you 3% improvement in the wind W capacity. So with all these numbers, some of you may be not sure what does it mean, right? As such, just maybe allow me to explain it in more detail. Okay, so let's put that. You just imagine that you win the lottery today, then you are crazy enough to buy two identical houses located at the exactly same place, all right? And then you install the coated steel roof on the house at the left-hand side here for your own use, all right? However, you use a UPVC roof with the similar profile as coated steel roof on the left-hand side, on the house on the right-hand side, right? So which means left-hand side, you're using coated steel roof. The right-hand side, you're using UPVC roof. In one day, both houses resist the same wind load. Since the coated steel roof is having the higher wind uplift capacity, the roof is still intact in a good condition without any damage. And so you're enjoying the space happily without headache, right? However, the UPVC roof on top of the roof stay by your brother, you feel it resists the same wind load, and then the water leakage happen immediately. And your brother only can use the bucket to collect the rainwater and then keep on cursing you. Right? So he explained that how the wind load capacity different will make your life different. Because a lot of people is just concentrating on the material, but the performance of the water leakage is more important than everything. Because when the water leak, it's not only you having a lot of problem that you want to seal it up, but you will damage a lot of asset inside your building. All right, let's talk about the performance value. So remember, every cent that you pay for a product is to buy the performance. So you must know what you are buying. For example, you pay higher for a car is to buy a higher CC, right? And you pay higher for a safe is to protect your properties or jewelry. Or you pay higher for a house is to get a bedding living space. All right? Similarly, it's applied for the roofing sheet. You pay a certain amount to buy a 0.42 mm BMT coated steel to protect you and your properties from the weather. Then you pay a higher amount to purchase the same product, but increase the thickness to 0.48 BMT. Hence, you should be expected that you gain more from the extra price you spend, right? So the coated steel at least provide 50% increment in the wind loading capacity to protection from the weather. However, you pay a certain amount to buy 1.8 mm thick UPVC roof, then you pay more to purchase the same product in 2.5 mm thick. You only get 3 increment in the wind uplift performance. Normally for your info, the price difference in between 1.8 mm to 2.5 mm thick UPVC is approximately 40%. So what consumer will get from the 40% price increase is just because it's thicker, because you can't really, because both of the performance of the wind uplift is more or less the same. All right. In short, is different product will give you a different performance. So none of the product in the world is perfect, and none of the product is flawed. It's totally flawed. However, you must know that what you are paying for and expecting the performance accordingly. All right. Okay, this is the second last quiz. So we are giving out 4 datum green tickets. So which of the following products will deflect or bend up severely and then outburst, break into pieces when it is filled in a resisting wind load? A is a coated steel product. B is a UPVC roof. So you can give your answer now. You have 10 seconds. But I think you have plenty of time because it's very straightforward that you can get the answer right. All right, another 3 seconds. And time's up. So yes, the answer is UPVC. UPVC roof, because it's too soft, it will easily bend up and also will outburst, break into pieces when you feel in resisting the wind load. All right, so now come to the gravitational load. So let's check it out about how the response of the coated steel roof to the UPVC when in dealing with the gravitational load. So similar to the wind uplift test, we set a testing criteria for the concentrated load test, and we call it as a point load test. In this case, we just compare the reaction of the coated steel roof and UPVC roof to the gravitational load. And we use 0.48 mm BMT coated steel roof and 2.5 mm thick UPVC roof in the comparison. The profile and the shape of both specimen is similar, which is as shown in the graphic here. The concentrated load test or the point load test were conducted by using the point load rate as shown in this photo, and it's carried out based on the AS1562.1 and AS4040.1. All right. So let's see how the coated steel react to the point load. So at first, when we start the test, we at the serviceability stage by apply the concentrated load at 92.5 kg at the underlap of the roofing sheet. So why this is we use it 92.5 kg? It is because we are referring to the testing standard AS4040.1. It assumed that an adult weight is about 92.5 kg. And when during the testing, they assumed that in the worst case scenario that the adult is standing with one leg and step on that one underlap. The roofing sheet is allowed to deflect, and then the side lap is disengaged. However, the roofing sheet must be returned to the flatness and the side lap is sealed again when the point load disappears. If the roofing sheet is back to the flatness, we'll continue with the test to the strength stage, which is we'll apply 274.5 kg load. This is simulate the point load from the construction load act on the roofing sheet. When the ultimate strength load removed, the roofing sheet should be back to the flatness. Otherwise, the roofing sheet is considered failed. All right. So refer to this photo. When the point load is applied on the coated steel roofing sheet, the area at the deflect or at the direct contact of the point load is the most deflect area, and then it's become less and less bended when the area is away from the direct contact point, right? So eventually you form a contour shape. So the smaller the contour shape is better because the bending of the roofing is lesser. So it's safe for the human traffic on the roof. So as you can see in this photo, the contour shape on the coated steel is small and localized when the point load apply on it. So it reduces the hazard to the human when people walk on it or work on it. All right, now let's take a look of the reaction of the UPVC when resisting the point load. So similarly to the test of coated steel, we apply the same serviceability load, which is 92.5 kg, onto the UPVC roof, and then we release it and observe the response. The results show that the UPVC roof is able to return to the flatness. It's a good thing. Okay, after that, we increase the load to 274.5 kg, and then we release it. The UPVC roof also can back to the flatness. However, the bending or the deflection is very severe compared to the coated steel. Let's take a look in the time-lapse video in the subsequent slide. Okay, here is a time-lapse video to show how the UPVC roof react to the point load. The roofing sheet bend lightly when at the serviceability load applied on it, which is 92.5 kg. However, when the roof will deflect severely when the strength load is achieved 274.5 kg. So almost half of the testing specimen is bend and deflect when the ultimate load applied on it. So this is how the deflection of the UPVC roof when the point load act on it. The contour shape is more severe than the coated steel roof. The deflect area is bigger. So as such, it creates an unstable, unsafe working platform on the roof. Worker may be easily slip or trip due to the uneven surface. So this might not be able to let you visualize what's the difference in terms of the safety, when walking on the coated steel or the PVC roof, right? So let's take a look on the next slide. Okay. The video on the left-hand side is show that the coated steel roof react when human walk on it. The coated steel roof is stable, rigid, and solid when people walk on it. No matter we walk on the purlin area or walk in between the purlin, the movement or the deflection is very minimum. As such, it is safe for the workers to walk on it. Right. Whereas the UPVC roof, whereas on the UPVC roof is too soft for human traffic, this video is show that an operator is walk on a multiple span UPVC roof. The roof is deflect easily and is wobble. For your info, the weight of this operator is only 60 kg. The roof is bent down easily, and especially the overlap area. As such, it's quite high risk then when the worker walk on it or do their work on top of it, because it is an unstable working platform. All right, this is the last quiz. We're giving out the 4 Titan Plus tickets. So very easy. Which is the following product is safe for human walk or work on it? A is a coated steel roof. B is a UPVC roof. You can give your answer now. All right, 10 seconds. It's pretty straightforward. You should be able to get the right answer. All right, and time's up. So the answer yes is a coated steel roof. All right, I hope you get all the answer right. All right, that's all for my sharing today. Let me just summarize the point of discussion. The wind uplift performance of the coated steel is higher than the UPVC roof. All right, so then the risk of the immediate water leakage during the storm will not happen on the coated steel because it will not crack or break on the surface. In addition, the non-affected area during the maximum wind load will be able to return to flatness after the wind load is gone. However, UPVC roof will be deflect and bend up permanently even though the wind load is disappeared. All right. And then then coated steel will not outburst or explode into pieces when it is filled in wind load, and the screw or the screw head will not fly off from the roof, so the hazard to the public is not an issue. So in reverse, UPVC roof will break into pieces and outburst when it is filled in wind load. In addition, the screw head will be flying out from the roof. All this reaction will create a public potential risk. All right. And then customer pay for the better performance product because coated steel at least can provide 15% higher wind uplift capacity compared to the UPVC roof. And coated steel roof even give 50% higher wind uplift performance if the customer pay more to buy a thicker product. UPVC roof is not only providing lower wind uplift performance, the manufacturer or the supplier charge higher for the thicker product, but only provide a significant improvement in the wind uplift capacity, which is only 3%. The coated steel roof provide a stable platform or mounting system such as a solar panel and a safety lifeline because it will not deflect or bend up severely when the wind load act on the roof. In the opposite, the UPVC roof is too soft, it's easily bent upwards when the wind uplift is coming in, and it will damage the mounting system. And lastly, is walking on the coated steel roof is safer than UPVC roof because it is strong and stiff and it is more stable. And in reverse, UPVC roof is too soft to let people walk on it. It's easily deflect or bend downwards when resisting the human traffic load. Eventually, it creates unstable walking platform and unsafe to walk and walk on it because it is having the high potential risk in terms of making the workers slip or trip on it. All right. Right, that's the end of my session today. Before I end the session, I would like to deliver a message. So just bear in mind that the same shape but making different material will not give you the same performance. So this sharing session, I hope already proved to you that the performance of the coated steel roof and UPVC roof will not be the same, even though the profile or the shape is similar, but made in different material, right? Right, that's it for my sharing session today. I hope you enjoyed it. So let me start to answer the question that have been posed into the Q&A chat box.